Welcome back, folks. Greg Silverman coming to you from Mount Sinai behind. No, I'm just kidding. That's somewhere in Hawaii. It's just absolutely gorgeous, isn't it? I just love that picture. Look at the trail, like sunlight coming down. Awesome. All right. Welcome back to Come Learn With Me, another session of Come Learn With Me. This article has to do with nanofibers, which is, well, that's going to be very interesting. We have biotech as our mini investing group. We'll list at the bottom of this the link to our LinkedIn investing group for biotech. If this kind of thing interests you. Anyway, this is a Come Learn With Me session. See if we can figure out some information ourselves. And if you hang with me, I'll send you some more good information your way to see how we invest ourselves in the biotech market. Okay, let's go. Nanofibers designed to stop brain tumor cells from spreading. I hope you guys have heard of nanofibers. Oh. Okay, I'll come back. Read 3 minutes. Our body heals its injuries by essentially replacing damaged cells with new cells. The new cells often migrate to the site of injury, a process known as cell migration. However, abnormal cell migration can also facilitate the transport and spread of cancer cells within the body. Glioblastoma multiforme is one such example of a highly invasive brain tumor that spreads via migration of the tumor cells. Okay. The frequency at which such tumor cells spread and grow make conventional tumor removal methods ineffective. Furthermore, options such as radiotherapy and chemotherapy are harmful to healthy cells and cause adverse effects. In order to develop improved therapeutic strategies, a precise understanding of the invasion mechanism of GBM cells is necessary. An alternative treatment strategy in considering involves capturing the migrating tumor cells. It turns out that cell migration is dictated by the structure and the orientation of the extracellular matrix, fibrous structures surrounding the cells. By engineering similar structures of desired geometries, it is therefore possible to exert control over the migration process. Elementary, dear Watson. Elementary. Now, in a study published in ACS Applied Biomaterials, researchers from the University of Fukui, Japan, have designed a platform based on nanofibers that resemble the ECM to examine their effect on GBM cells. We fabricated a nanofibrous sheet in which the fiber density changes from end to end gradually using a technique called electrospinning, and carried out a culture experiment of brain tumor cells, says Dr. Satoshi Fujita, who headed the study. All I can say is like, wow, right? Unbelievable. Researchers observed clear distinctions in cell movement in nanofibers of different densities. They found that the denser fibers promoted the formation of focal adhesions, clusters in the cells that resulted in a slower cell migration. Taking advantage of this negative correlation between cell movement and fiber density, the researchers were able to control and direct the migration of cells by designing a nanofibrous sheet with stepwise varying densities. By arranging the fibers in a high to low density configuration, they were able to restrict the movement of cells as most of them were captured in the high density zones. On the other hand, a low to high density configuration, the opposite effect and encouraged migration. In addition, they noticed that the gaps between the zones hindered cell migration, leading to cells being trapped in the high density zones. This one-way migration was observed for the first time, and researchers named it cell trapping, after fish and insects traps that cause their prey to travel along a single direction for trapping it. Sure. The study demonstrates the feasibility of capturing migrating cells using electrospun nanofibers that mimic the microenvironment of the brain. That truly is science fiction, guys. Come on. Huh? Fibers in the brains, making fiber in the brain. That's small. With such remarkable findings, the team decided about the future prospects of their nanofiber-based platform. It is available for the design of scaffolding materials, which are the basis of regenerative medicine, in combination with various fiber processing technologies and material surface treatment technologies. This could lead to the development of practical applications of regenerative medicines, speculates Dr. Fujita. In addition, it can be used as a processing technology for cultural carriers for efficient production of biological drugs, including proteins, antibodies, and vaccines. All right, a highly technical document, I would say. Well, technology networks, which was super interesting. We follow longevity is a theme that we followed for a long time. I've got some nice podcasts that I did with Dr. Aubrey de Grey, who's a leading specialist in the space, and yeah, it's fascinating. So maybe we'll put a link to that one down below. All right, you want to know more about investing in biotech, investing in other niche areas? Uranium's another specialty of ours. We also do some mining, gold and silver mining stocks. So head over to this URL and come hit us up and get to know us. And let's see if we have something that would interest you on the investment front. So Greg Silverman, thank you for joining me for another Come Learn With Me session. Out for now.